All right, lesson 3, we are going to talk about multiplying and dividing monomials. So we're going to start the lesson by talking about the product of powers. So there is a rule, and you probably remember this maybe from a previous math class. If you have 2 to the 4th times 2 cubed, how many of those do you actually have? How many of them do you actually have? So 2 to the 4th is going to be 2 times 2 times 2 times 2, and we're going to multiply that by 2 to the 3rd, which is 2 times 2 times 2. So how many of those do you actually have? 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th. Now you can do that every time, or you can say, if I have 4 of these and 3 of these, then now I have 7 of them, and you can just add these exponents together. That is the product of powers rule. Product of powers rule. Now that only works with like bases. So since they were both a 2, that will work. You couldn't do 2 to the 4th times 3 cubed because those are not like bases. Works the same thing with numbers as it does letters. Notice these are both the same base. They both have an A. This says A to the M. This says A to the N. So what is that actually? A to the M plus N, because you were just adding those exponents. So when we talk about monomials, here's the definition you need for this. It's a number, a variable, or a product of a number and one or more variables. So a monomial could be 3 squared. A monomial could be a to the m. It could be 3a to the m. Could be a big combination of that, but it's just one. It's just one piece, or it's a product, so things that are put together like 3a to the m, that would be a monomial. All right, so if you talk about 3 squared times 3 to the 4th, 3 squared means you have 2 of them. 3 to the 4th means you have 4 of them. So how many do you have altogether? 6. Oops, sorry about that. 3 to the 6th power. That's what we've got. Okay, let's move down here and see what we've got. It says simplify using the laws of exponents. So that we just did. Simplify using the laws of exponents. All right now. Gets a little carried away sometimes. Let's go back here. Number 1. 5 squared times 5. Now I want you to realize that anytime it says times 5, that means 5 to the 1st. Anytime you do not see an exponent, you assume it's a 1. So here you have you have 2 5s. Here you have 1 5, so we're multiplying. The bases are the same. So we actually have 3, 5 to the 3rd. And you can just leave it like that. You do not have to take it all the way out if you do not want. Number 2, we have c to the 5th times, c cubed times c to the 5th. So here we have 3 c's, here we have 5 c's. This means c times c times c, c times c times c times c times c. So how many do we have? We have 3 here and 5 here. We add those together. That is why it is c to the 8th. All right, now if your monomials have a coefficient in front, which is what the number part is in front of that, if that is the case, you need to multiply the coefficients. So negative 3 times 4, that's where this negative 12 comes from negative 3 times 4. And then we've got x squared times x to the 5th. Bases are the same. Doesn't matter the numbers in the front. Does not matter what the coefficients are. The letters are the same. So if the letters are the same, you can simply add the exponents. So we've got 2 x's and 5 x's. That leads me to 7 x's. So my final answer, negative 12 times x to the 7th. Now I want you to try these 3 here under got it. Pause it, try them, and I'll be right back to give you the answer. All right, hopefully you tried them. Under A, we've got 9 cubed times 9 squared, which will lead us to 9 to the 5th, because we would have 5 of them. Same bases on B, so add the exponents. That would be a to the 5th. Both have a coefficient on C, so you multiply that, and negative 2 times a negative 8 is a positive 16. M does not have an exponent, so we assume it to be a 1. So we've got 1m and 5 m's will give us m to the 6th. Okay. Moving on. go to the next page. So we just did multiplication of powers. Now we need to do division of powers, so the quotient of powers rule. So just as you would think, if you multiply like bases, you add the exponent. So when you divide like bases, you should subtract them. You should subtract them. So if you have the same base, you can take the exponents and subtract them. Okay, it works the same with letters. A to the m divided by a to the n is a to the m minus n. Now, here's what it looks like. If you have 5 to the 7th, what that actually means is you have 1, 2, 3, 4, 5, 6, 7 fives. If you have 5 to the 4th, you have 1, 2, 3, 4 fives. You can cancel. 1 on top, 1 on bottom, 1 on top, 1 on bottom, 1 on top, 1 on bottom. What do you actually have left? You have 3 fives left. That is where 5 cubed comes from. 5 cubed. All right, so if I have 5 cubed, I could have simply got that from 5 to the 7th divided by 5 to the 4th. I could subtract my exponents. I could subtract them. Let's look at some examples here. Example 4. Simplify using the laws of exponents. 4 to the 8th divided by 4 squared. I have like bases, so I can subtract the exponents, 8 minus 2, and get 4 to the 6th. You do not have to work that out. Into the 9th divided by into the 4th. Like bases, I can subtract the exponents because I'm dividing 9 minus 4 into the 5th. This one, 2 to the 5th times 3 to the 5th times 5 squared divided by 2 squared times 3 to the 4th times 5. So, if they are like bases, remember you can subtract the exponents. So we have a base of 2 right here. Exponents were 5 and 2. I can subtract them, 2 to the 3rd power. I have base of 3, exponent 5 and 4, subtract them, 3 to the 1st. Remember, if I do not have an exponent, I assume it to be a 1. So 5 squared divided by 5 to the 1st is 5 to the 1st. Now, I would be happy leaving this right here. To me, that is fine. I did not make you work out the other ones. I would not necessarily make you work that one out either. But if you did 2 times 2 times 2 is 8, times 3 is 24, 24 times 5, 120. So that's where that comes from. All right, let's go down and do a few more here. Underneath, got it. I want you to try them quickly on your own, and then we will talk about answers. So hopefully you did, and you're back by now. So we have 5 to the 7th divided by 5 to the 4th. Subtract our exponents. D is 5 cubed. Looks like an S, sorry. It's 5 to the 4th. Sorry, 5 cubed. 7 minus 4 is 3. Okay, E, like bases. X to the 10th divided by x cubed, x to the 7th. Whenever I have coefficients in front, just like I did on the multiplication, I multiplied them. So if I have numbers in front, I just divide them. So I would have 6, w to the 5th, w to the 1st, would leave me with w to the 4th. Like basis, subtract the exponents. So on G, 3 squared times 5 to the 1st times 7 squared. I'm just subtracting those exponents. On H, 5 squared times 7 squared times 8, or 8 to the 1st. Last one on I, -2. Make sure you keep that in parentheses. To the 3rd times 3. Remember, there's an exponent of 1 there. 3 cubed times 5 cubed. You can always subtract exponents if you have like bases. Okay, let's go on to do a few guided practice, and then this lesson is done. Next page. Come on, honey, come on, honey. Sometimes if you talk to it, it makes it go faster. All right, guided practice. Simplify using the laws of exponents. So number one, we are multiplying. And when you multiply like bases, yeah, see, talk to it too much, didn't I? That's what I get. Just like a kid, they'll prove you wrong every time. Well, my own kids anyway. Number one, 4 to the 5th times 4 cubed, adding exponents because I am multiplying, gives me 4 to the 8th. Number two, multiply my coefficients. -6, a to the 5th, because I've got a 1 right there. Number three, I've got y to the 8th divided by y to the 5th, so I'm going to subtract my exponents, y cubed. Number four, 24k to the 9th divided by 6k to the 6th. Sorry, top of that was cut off just a little bit. So divide my coefficients gives me a 4k cubed. These, exponent of 1. 2 squared divided by 2 to the 1st. I've got 1 left. 2 to the 1st times 3 squared times 4 to the 1st, or I could just simply write a 4. And last one. Keep that in parentheses. -3 squared, subtracting the exponents of like bases, times -4 squared, because this does not have an exponent, so you assume it's a 1. This does not have an exponent, you assume it's a 1, times 5 to the 1st, or you can simply leave it a 5. So with that, that brings us to the end of this lesson on the product rule and the quotient rule. Remember that if you are multiplying like bases, you add the exponents. If you are dividing like bases, you subtract the exponents. Okay, good luck. If you have any questions, let me know.